Now we need to learn about the frame format, the Ethernet frame format. And what you need to know is that the same hardware, the same physical and logical topology of connectivity used in Ethernet, the same devices, the same interfaces, the same hubs, support two different frame formats. One is the Ethernet 2 format. That format of the frame was defined by DICS, that is Digital Equipment Corporation, Intel and Xerox in the 70s. And in this case, then we start transmitting from the left to the right. That is, the first bit transmitted is this one, and the last bit transmitted is this one. The first bits transmitted are called the preamble, and the preamble is used to synchronize all the recipients, because when a station transmits, there could be several stations receiving, not only one. And the synchronization of the transmission is performed based in the use of, for instance, a Manchester coding, that is self-synchronized coding. In that way, the receptors, the reception entities, could synchronize using that, for instance, that Manchester modulation or coding, and use those 8 bytes, that is 64 bits, to synchronize the sampling of the signal according to the clock of the transmitter. After the preamble, start, in fact, the logical frame, and the frame, the Ethernet 2 frame, has different fields. Field of 6 bytes, that is 48 bits, where the transmitting station specify the destination address, the MAC destination address, the medium access control address of the destination station. This destination address could be a unicast address, that is typically the MAC address of an interface of a station within the broadcast domain of propagation of the frames. And after that, those first 6 bytes, the transmitting station will send 6 bytes, that is 48 bits, coding the source address. In that case, typically is the MAC address of the sender. In the case of the destination address, we could, the transmitting station could specify here a broadcast address. Typically, a broadcast address, we will see that, is, for instance, a broadcast, an address that consists of the 48 bits in one. 48 bits in one. In that way, all the stations in the broadcast domain will receive the code and store that frame, and that frame will be interpreted, will be analyzed by the layer 2 the data link layer of the destination stations, all the destination stations in the broadcast domain. Well, then in the Ethernet 2, we have two fields, destination address and source address. Here we the sender place or code MAC addresses. After that, after those fields, the sending station will code 2 bytes, that is 16 bits, that represent what we call the frame type. The frame type is a number that indicates to the other entity, to the other layer 2 or to the other data link entity at the destination station, which is the protocol encapsulated in the payload of the frame. This payload then has to contain at least 46 bytes and a maximum of 1,500 bytes. Then, for instance, this number, 1,500 bytes, is the MTU of Ethernet 2, the maximum transfer unit of this standard. And when we need to place here at least 46 bytes is because the frame has to be at least 64 bytes length. Then if you calculate, we have 8 plus 12, that is 20, 22, 22, 26, 26, then 64 minus 26, we have as a result this quantity of bytes that the payload must have. If the data that the upper layer need to transmit is shorter than 46 bytes, the data link layer of Ethernet will complete the information in this field with null bytes. That is bytes with 8 bits in zero. Finally, the sender at the end of the frame transmission will transmit 4 bytes, that is 32 bits of a frame check sequence that typically is a cyclic redundancy check, a CRC of 32 bits, calculated over the frame that was sent to the network. In that way, when the destination station receives all the frame, the destination station could calculate a CRC, a cyclic redundancy check, over all this frame and compare this CRC with the information that the frame content at the last field called frame check sequence. And if the information differs, then the receiving station will detect an error and discard the frame with that were received with error. In the case of, but the Ethernet does Ethernet 2 is not the only frame format that could be used in an Ethernet network. We could use another frame format called 802.3 or 802.3, because in fact this frame was specified by IEEE in February of 1980, and then perhaps one decade later of the definition of the Ethernet 2, but they introduced a quite different format of frame, and the frame then differ in this field, that is a field called length, frame length. And then in order to if we remember, the frame could have a maximum of 1,500 bytes. Then in fact this number is lower than the minimum number that Ethernet use in this field, in the frame sequence, in the frame type field. Then when the destination station receive a frame, the destination station could learn if the frame is an Ethernet 2 frame type or frame format, because this number is higher, for instance, of 800 in hexadecimal. That is higher than 2000. Is a number higher than 2000. But if this field contains a number lower than 1,518 bytes, the destination address interpret that this is a IEEE 802.3 frame format. Within this format, we have other fields in the header. For instance, the destination sub, source sub numbers that identify the entities at sublayer called the logical link control sublayer. And in this field, the control field, they specified which type of frame is transmitted, but typically all the protocols that use this frame format use the transmission of unnumbered information frames, and then this is coded in this field, and that's why then if we use for instance a frame format like this to transmit messages like those transmitted in Ethernet 2, in fact, we will transmit here in the payload of of this frame the data of the upper layer across the network. And finally, this field is used in the same way as this field in Ethernet 2 frame format. Now we need to talk about the structure of the MAC addresses, the medium access control addresses used in Ethernet technologies and other local area network technologies. Remember, each MAC address has a length of 6 bytes, that is 48 bits. The MAC addresses are traditionally represented as a sequence of 6 two-digit hexadecimal numbers separated by colons, or in some platforms, there are no colons separating those 6 two digits, 2 hexadecimal digits. Remember, an hexadecimal digit has 16 combinations from 0 to 10, A, B, C, D, E, and F. And in the case, for instance, this is a typical notation. In this case, we see that every 48 bits are in 1. And that's why we have this notation. That is, we have 12 digits with F. This particular address is used for broadcast addressing. That is, when a sender need to send a frame, a MAC frame, to every station, every node within the broadcast domain. That is, all the stations that will receive a frame, a broadcast frame or a unicast frame from any other station within that broadcast domain. When we need to transmit unicast, that is frame to only one station within that broadcast domain, we need to specify that the first, the most significant bit of the MAC address have to be in 0. And if that is the case, the other bits, the other most significant bits, typically the first, the 3 most significant bytes are defined by the vendor, the provider of the network card. That is, then the network cards have a globally unique MAC address, which is managed globally by the IEEE and the manufacturer. And then the lowest significant bits of the MAC identify each card associated with each manufacturer. That is, those 3 most significant bytes identify the manufacturer of the interface, of the network card. And these 3 less significant bytes identify the network card of that manufacturer. In that way, we could use those addresses to identify any interface, any Ethernet interface in a network. We were talking about two different frame formats that could be used within an Ethernet network. But in fact, what you need to know is that the Ethernet 2 frame format is the most used because, for instance, here in the payload, we encapsulate typically Internet Protocol messages, that is datagrams, IP datagrams, or for instance, um, ARP, Address Resolution Protocol messages. But in some cases, we could use this frame format, this IEEE frame format. For instance, for the well-known protocol called spanning tree protocol. In the case of using the IEEE frame format, we need to know that as here we specify the length of the frame, we need to specify at any place of the frame which is the protocol that is encapsulated here. That's why we need additional fields, an additional header, and this is accomplished by another sublayer in the data link layer called logical link control. And then what we need to know is the data link layer, the OC data link layer has been divided into sublayers by the IEEE group, that is the 802.3 group, and they define that there is a sublayer called MAC, Medium Access Control sublayer, and sublayer LLC, Logical Link Control sublayer. And the PDU of the LLC sublayer is encapsulated into the PDU of the MAC sublayer. That's why here you are. This, in fact, this is the LLC frame or LLC PDU that is encapsulated within the payload of the MAC sublayer frame. And then what we need, what you need to know is that the IEEE defines three different types of LLC services. Each LLC service is identified in those fields, that is in the destination, source sub, and control fields. And there are typically three types of LLC services identified as LLC1, LLC2, and LLC3. LLC1 is a service equivalent to the service provided by Ethernet 2. That is the proposition, the protocol defined by DICS, by Digital Equipment Corporation, Intel and Xerox. Then, when we use Ethernet 2, in fact, we obtain from the data link layer from this entity service that that has those characteristics. Is unconfirmed because the frames contain information, but if the frame is received with errors, it will be discarded, and it is not the responsibility of the Ethernet 2 entity to retrieve, for instance, to retransmit the frame in order to face that error condition. And is a connectionless service. That is, the stations exchange simply unnumbered information frames that are called Ethernet 2 frames. That's all. Then what we could understand is that Ethernet 2 service is equivalent in terms of functionality to the LLC 1 service proposed by IEEE. There are two other LLC services. LLC 2, that is a connection-oriented services that provide protocol, is in fact a protocol that detect errors and retransmit the frames if an error occur, and then that protocol is a connection-oriented protocol that support, for instance, ARQQ, typically automatic repeat on query mechanism, retransmitting lost frames, and using what is called a sliding window mechanism. But the third LLC service, the LLC number 3 service, is in fact a connection-less service like the number 1, but with confirmation. Is a confirmed connection-less service. That is, typically could be used to simply use a mechanism called ARQ, but stop and wait, an automatic repeat on query mechanism, but without window, or in fact with a window size of 1. The station transmit an information frame. If the information frame is not received correctly, then the station will retransmit the frame. But in fact, nowadays LLC1 is used almost exclusively as protocols. For instance, to transmit protocol, for instance, like spanning tree protocol, but using only the LLC 1 service type. The other service types are not really used nowadays.